What we're going to do now is we're going to play around with this identity matrix, and we want to use it. We want to use this identity matrix not to get the same matrix back, but to get a third matrix where two rows have either been swapped around or they've been manipulated somehow. We have 1, 2, -3, and then we have -3, -4. Okay, what we want to do is get this matrix gradually into upper triangular form. So to do that, we need this -3 to become 0. Then we want to get this 2 to 0, and then get this 1 to be equal to 0. So these numbers, we must get to be equal to 0. Okay. Using this identity matrix, or an adaptation of the identity matrix. Let me show you something. I'm going to copy this code. And instead of having 1, 1, 1, I'm going to go 1, 1, 1 in the opposite direction. So I'm flipping the axis. Let's see what happens when I do that. I'm going to call this I underscore. Now watch what happens when I do that. Can you see what has happened? The third row, which is 2, 1, 5, is now at the top. And the first row, which is 1, 2, -3, is now at the bottom. My point is, the way we would, where we put a 1 is going to allow us to, well, perform row operations. Let me see if I can give you a very simple example. A very simple, and we'll come back to this original one. So I'm just going to create a very small matrix. Let me call this a M, just a 2 by 2. And let's make this 2 and 0. And we'll make this 1 and 1. Okay. I want to solve this matrix using a modified version of the identity matrix. Okay. So we have 1, 0, 0, 1. 1's across the diagonal, obviously. Like before, if I were to multiply these matrices, I would get back the same matrix. Okay. 2, 0, 1, 1, 2, 0, 1, 1. Now, if I want to solve this matrix, I would have to subtract 2 from 1. So what I'm going to do now is I'm going to call this E for elimination. So this is the original matrix, right? Again, that's the identity matrix. 1 on the principal diagonals. If I set this to -1, here's one way to read it. Let me actually plug in more numbers in here just to expand, just to make this bigger so you have a better idea. I will make these 0 down here. Again, if I set this to 0, you have an identity matrix. If I set this to -1, basically here's one way to interpret it. We're saying add to the second row the difference of the first row. Add to the second row the difference of the first row. So whatever 2 is, so imagine this is R1, this would be R2, this would be R3. This is how you read the rows of an elimination matrix. Add to row 2, -1 of R1. So basically multiply these by -1 and add it to the second matrix, the second row. I just want to make this part clear. So let me just add this comment here. So this is R1, R2, all of these are R1, R2, 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 and everything here is R3. So basically, here's what I'm trying to say. Okay? Because the elimination matrix is a type of encoding matrix. If you keep what's across the diagonal to 1. So if I keep this 1, I'm saying keep row 1 what it is. If I make this 1 and the other 0, I'm saying do not change row 2. Keep R2 what it is. And if I set these to 0 and I make this 1, then I'm saying keep R3 what it is. If, however, I make this 1, I'm saying keep R3 what it is, but add R1 to it. So it's like I'm activating row 1. Row 1 will be added to row 3. So for example, let me make this 0 again. Okay, once again, we will get the same matrix. But I'm trying to get across this idea that we can play around with this identity matrix to eliminate and get to the upper triangle. So let's return to the above example and do this again. Okay, I'm going to go back to the identity matrix, set these to 0. Okay, I'll do one example. When I get to the second and third elimination matrices, you should get the idea. Okay, so if I run this now, I'm going to get the same matrix. So 1, 2, -3, 1, 2, -3. -3. I hope you can see they're all the same. Okay, now I'm going to make this my first elimination matrix. To get to my first elimination matrix, I need to get rid of -3. I need this to become a 0. So what I'm going to do is I'm going to create my first elimination matrix. This will be a modification of the identity matrix. So to get rid of this, -3, I need to multiply row 1 by 3. So this will become 3, this will become 6, this will become -9. And then add this row to the second row, because 3 plus -3, they cancel each other and we get to 0. So I'm going to go -3. Okay. And then I'm going to multiply them together. So I'm going to multiply my first elimination matrix times 8. Okay. Is this supposed to be -3 or 3? It's supposed to be 3. So you see here, our first row is the same. Our third row is the same. But now we have discarded the leading -3 in the second row. That's my first elimination matrix. And so I will now reassign A to this evaluation. Okay, so my A has been updated.